Today we're going to learn a little bit about SOHCAHTOA. I hope this isn't bringing back too many bad memories from high school.
I did get a brief flashback, but then when I saw Toa, I remembered Matanui and Bionicle, and that made me feel a little better.
I don't remember that, but
Well, I
whatever
did.
makes
Very
you feel
niche
good.
audience that knows what I'm talking about.
So, let's start with SOH. S-O-H. This stands for sine theta equals opposite over hypotenuse. What do you think the C stands for?
Is that cosine?
Yes. Cosine theta equals, what do you think the A stands for?
Hypotenuse?
No, not an A.
Oh,
H is hypotenuse.
you're right. I got ahead of myself there. Okay. I have no idea.
That's okay. It's going to be adjacent over hypotenuse. Now, TOA. This one is not actually about Bionicle. What does T stand for?
Okay, so not Toa Tahu. That would be tan.
Tan. Tan of what?
Tan
What is this?
over...
What is this called?
I don't know what that is.
That's theta.
Data? Or theta?
Theta, yeah. It does kind of sound like a D. So theta is representing the angle of our triangle. We're going to get into that in a second. So tan theta equals, what is the O?
Over?
Over? Not over. What was it in sine?
Theta?
It's actually going to be opposite.
Opposite.
And then what is A?
That's the adjacent, right?
Yeah, perfect. So notice, in sine theta equals opposite over hypotenuse, the O in SO is for opposite, and the H is for hypotenuse. Sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. Tan equals opposite over adjacent.
So these are our new equations, where we can plug in one of these three things, or two of these three things, to find what's missing of these three different possibilities.
Yeah, oftentimes. This isn't going to be so much like as straightforward in the sense that this is more of trigonometry. So it's going to make more sense once you see these triangles. Let's draw a right triangle. What is a right triangle? Why is it called a right triangle?
It has a 90-degree angle.
Exactly. It has a 90-degree angle, which is kind of like the corner of a page. Now, I'm going to place my angle of interest here for now. Theta represents the angle of interest. So, what is this side that is opposite from the right angle called? It's a little off-putting, but what is this longest side going to be called?
The longest side, is that the hypotenuse?
Yes, exactly.
Okay.
This is the hypotenuse. A very memorable word, even though it's so weird. Okay, now this side here is across from our angle theta. What are we going to call this side?
Is that cosine?
Not cosine. I'll give you a hint. It's either the hypotenuse, the opposite, or the adjacent.
Oh, okay. Is that the adjacent?
It's actually going to be the opposite because it's opposite from theta.
Oh, and this is from its relation to wherever our interest is.
Yes, wherever the angle of interest is.
So if the angle of interest was that other point, the opposite and the adjacent would be flip-flopped.
Yes, but the hypotenuse would stay the same because the hypotenuse is always the longest side. So that leaves this side to be the adjacent. Let's do a quick example of this. Let's actually flip it up just a little bit just to make sure that you don't really care about the orientation of the triangle itself. I'm going to put the angle of interest here. We know that this is our 90-degree angle. Let's say that our hypotenuse is 5, the opposite's 3, and the adjacent is 4. What is sine of theta equal to?
Sine of theta equals the opposite over the hypotenuse?
Yep. Perfect. What is the opposite equal to in this case?
The opposite in this case, would that be equal to 3?
Yes, and what is the hypotenuse?
5.
Right. So sine of theta equals 3/5. What is cosine theta equal to?
Cosine theta is equal to the adjacent over the hypotenuse.
Right. And in this case, what is that?
In this case, would it be 4 over 5?
Yeah, perfect. Cosine theta equals 4/5. Finally, what is tan theta equal to?
It's the opposite over the adjacent, and that would be 3 over 4.
Right, perfect. There we go, already getting there.
So is this a geometry refresher, or do you think you would learn this in a physics lesson?
I think that most teachers would review this, but they don't strictly have to. This is kind of like a geometry subject. It's just used a lot in physics. So most physics teachers would reteach this because it's so important whenever we get to two-dimensional kinematics, and honestly, it's constantly useful in physics. I'm just going to give you more stuff like this. Now, I don't know if these angles are going to be perfect, but I'm going to do my best. Let's explore one more aspect to this. Do you remember the Pythagorean theorem?
Is that a squared plus b squared equals c squared?
Yeah, it is.
Oh, awesome.
I bet you've used that answer for like a million things, just double checking, and this time it stuck. I was kidding.
Yeah, it's just like when I say the mitochondria is the powerhouse of the cell, and I'm just repeating it.
Exactly.
You know, like
Matt, we're going to need your social security number for your taxes. Is that a squared plus b? No, Matt. You've tried this 100 times.
My employee identification number is E equals MC squared.
Is it the powerhouse of the cell? No, Matt.
Caught in 4K, man.
Yeah. We're gonna need your social security number. All right, but Pythagorean theorem, you're correct, is a squared plus b squared equals c squared. I made that m a little funky, but that's okay. So these are referring to the sides of a triangle. A, B, and the hypotenuse is always C. However, A and B don't matter. It doesn't mean that A has to be the adjacent and B has to be the opposite. You can flip-flop those, it doesn't matter. So this would have been the same if I did this.
And doesn't a triangle always add up to 180 degrees?
The angles of a triangle do, yes. But the sides do not. You're totally right though. So if this is 90 degrees here, and let's say that this one is 60 degrees, theta is equal to 60, then that would mean that this one has to be equal to 30 degrees, because 90 degrees plus 60 degrees plus 30 degrees equals 180 degrees.
Got it.
Now, let's say I tell you that A is equal to 4, B is equal to 3. What should C be equal to? This is gonna
81?
Not 81, but that's a good thought. So you did 9 squared, right?
Yeah.
Not quite how we're gonna do it. So let's plug in A. A is 4 squared plus B squared, right? A squared plus B squared equals C squared. What is 4 squared?
16.
16. What is 3 squared?
9.
9. Can we add those two up?
Yeah.
Let me know what you get.
Okay, so we have 25.
Nice. 25 equals C squared.
Oh, is that 5 then?
Yeah, perfect. So the last step is you take the square root of both sides to get rid of that square. And yeah, the square root of 25 is 5. So C equals 5. So it turns out that the triangle I drew up here is actually accurate because it's a 3, 4, 5 triangle. And that's a pretty common one. Let's see if we can come up with a few more of these. I'm going to go to the next page here. Give me a number, Matt.
8.
8. Give me another number.
7.
7. I'm going to redraw this so that it's like this. The longer side will just be that one. This is our 90-degree angle. For now, does it even matter what side our angle of interest is on for Pythagorean theorem?
I don't think so.
No, it doesn't care about that. But we need to find this hypotenuse.
So you would find 7 squared plus 8 squared, and then find the square root of the answer to find C.
Yes.
That would be
kind of a cool
49 plus 64.
Probably not going to be a very nice number, is it?
Yeah, I have to find the square root of 113, which might not be pretty.
Yeah. I don't think there really is a clean square root to 113. I know it's going to be between 10 and 11 because the square root of 100 is 10 and the square root of 121 is 11.
Like I got 10.6.
That sounds about right to me. So for this answer, you could always put 10.6, or it's acceptable to leave it in radical form. Whenever it's still under the square root symbol, that's called radical form.
Gotcha.
This is a radical. So, pretty good though. Now, let's just replace this with 10.6, make it easy on ourselves. And I'm going to put the angle of interest here. Can you find sine theta? What does sine theta equal?
Is it the opposite over the adjacent?
That's tan. That was TOA. Tan theta equals opposite O over adjacent. Remember SOH, S-O-H. What is sine theta equal to?
Oh, so it's opposite over hypotenuse.
Yes, exactly. Opposite over hypotenuse. What is the opposite side here in this triangle?
Okay. The opposite, is that 7?
Not 7, because 7 is touching theta.
Okay, so that would be 8.
Right. So 7 is the adjacent because it is adjacent to our angle. 8 is opposite because it is opposite to the angle of interest. This would be different if I had put theta over here. If I'd put it on the other side, then 7 is the opposite and 8 is the adjacent. Making sense?
Yeah.
But we'll go back to the original. Theta's up here. So you said that the opposite is 8. So we put 8 on top, and it's opposite over hypotenuse. What's the hypotenuse?
10.6.
10.6. Perfect. We could reduce this if you want to. You can get it into a fraction, solve it on the calculator. But sine theta is 8 over 10.6. Nice, not bad at all. What is cosine of theta here?
Cosine is,
Remember,
is it the opposite?
Ka. So, ka, toa.
Adjacent over hypotenuse.
Yes, perfect. This is why we have SOHCAHTOA, because it helps us just to remember that order. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tan is opposite over adjacent. So not only is it important to remember SOHCAHTOA, it's also important to remember how it's spelled, because it's not always that obvious. Some people might think ka is C-O-H, but it's not. Ka is C-A-H. So is S-O-H. Toa is T-O-A.
All right. So
what is it for this triangle?
That's 7 over 10.6.
Perfect. And what is tan theta equal to?
That would be 7 over 8.
Close. It's opposite over adjacent.
Okay, so is that 8 over 7?
Yes, because 8 is the opposite in this triangle, and 7 is the adjacent. Perfect. All right, Matt, great stuff. I think that's enough for this session here.